Hello, good morning. I am Gokul Raj. I am working as assistant professor in electronics and communication engineering department. Now I am going to explain microprocessor. Microprocessor is a IC which performs all arithmetic operations, addition, multiplication, subtraction and other logical operations also. Now microprocessor we are going to see is 8086. There are so many microprocessors like 8085, 8080, Zlog 8080. In that family, Intel developed a microprocessor of 40 pin IC, that is 8086 microprocessor. Okay, it is a 40 pin IC having 16-bit data and 20-bit address lines. Now in this session we are going to see the block diagram of the microprocessor and how the address can be calculated for the 8086 microprocessor, since it is coming under the CISC microprocessor family, and a sample program which performs movement of block of data byte, that is 8-bit, from one place to another place without overlap. The block diagram involves a microprocessor and its architecture, and is connected in between memory subsystem and IO subsystem. The memory can be classified as RAM and ROM. In RAM we have dynamic RAM and SDRAM, which can be connected to the microprocessor in order to fetch the data and manipulate it according to the instruction given by the input-output system. The example for input-output systems are keyboard and mouse, printer. These are all the examples for the IO system. Since the 8086 has 16-bit registers, namely code segment register, data segment register, extra segment register, stack segment registers, whereas the address calculation belongs to the outside unit which can be able to do by the users. For that sake, the address pins is 20-bit, whereas the inside the microprocessor the registers are of size 16-bit. So there is a special calculation is needed for 8086 to be programmed. So the first step is how to calculate the 20-bit address, because from the outside view 20 bits are for the address. 20 pins is mapped to the 20-bit address A0 to A19, whereas the effective address is the segment registers address. We have seen CS, DS, SS, ES. The 16-bit address is taken from any of the segment registers, and the instruction pointer is shifted towards the left hand side, and if we add both the shifted value to the segment address, you can able to get the 20-bit address. This 20-bit address is going to visible for our knowledge. Using that knowledge we can able to locate the programs running place, execution place. So the block diagram here shows the address calculation method. The first one is effective address, which is derived from the any of the 4 segment registers, and the next one is IP, instruction pointers 16-bit. If we shift towards the left hand side, we can able to get the 20-bit address. The 20-bit address, the name is called physical address. Now we are going to see the program which is used for copying a block of data, that is 4 values copied to another memory location without overlap. So for that we are using the assembler. The assembler is the one used to convert high level language into low level language. Next we are going to link the program where it is mapping to the corresponding hex values. After linking is done, we are going to debug without generating the X file. That is called debugging mode. The first line dot model small tells you to add the library files where it has all the definitions for registers and other instructions sets. Next, we are going to give the data region in the data region. Next, after following the data X and Y of type byte whose width is 8-bit and the values are given one another one. For the Y, it is termed as destination register whose value is 10 duplicated to 00, that is uninitialized, whereas X1 is 11H, X2 is 12H, X3 is 33H and X4 is 44H, whereas Y0 is 0, Y1 is 0, Y2 is 0, Y3 is 0, like that it is duplicated. So these two lines is forming an array. After following the data, you have the code where you can able to give the logic, your logic operations. So now we are going to initialize the data segment register. We have the 4 type of registers. Among the 4 type of registers, we are going to use the data segment register, DS. So the data segment register is one initialized by move AX, at data by the indirect addressing mode and move DS, AX. Now the accumulator is having the address of the data segment, that is the X value. After the instruction LEA, load effective address, and we are choosing the index registers. In 8086 we have source index register, destination index register, and then a stack index register, instruction pointer. So among that you are using a source index and destination index, and we are getting the value from X and Y to the SI and DI. After following this, after getting the address, we are initializing a counter where CX is a 16-bit is used to load the value 005H. How many values here it is, that much value you have to take here. After taking that CX value, you are now going to exchange the value. The content of the SI, this is indirect register indirect addressing mode. The content of the SI, that is the 11H, is copied to the AL. Following that AL content 11H is copied to the first memory location. After that we are incrementing the SI. Now the instruction pointer will be denoting 22H. Next incrementing the DI, second value of the Y. Next decrement the CX, which is becoming 4. Next, if it is checking the condition CX for 0, if it is not equal to 0, you will once again go to the exchange operation where 22H is copied to the AL and 22, the content of the AL22 is copied to the DI register, so that we can able to exchange the data 11H here, 12H, 22H, 33H, 44H from X to Y until it gets 0, CX gets 0. So after the CX is becoming 0, the 4 values has been over, then the move AH, 4CH is the one we are loading the value, and interrupt 21H we are calling to end the assembler derivative. After following that, the assembler execution, we are using the directive called end to end the assembler instructions. Next we are going to see the interrupt concept.